meet up with a Luke Skywalker. That would be a cool scene.
I thought about them making new Back to the Future. You know the one where they come in 2015? Is that the year 2015? Yeah. They come to 2015. I say they should remake that movie, but make it after 2015.
I did not know about that part.
Like one of the movies, they go to the future.
The future is the past. It's a loop. No.
Oh my God, Google, come on,
The timeline is a loop with no exit condition. All right. Well, since we are all here, or most of us are here, so we are going to get started. Today's, I will give you your last homework assignment. It is worth 100 points, so it is a big deal. Well, it's a bigger deal than the ones before. But once again, all the homework assignment only add up to 20% of your final grade. So that means, it is a good way to practice and get hands-on experience with the concepts. But as far as your actual grade is concerned, the homework cannot make really a big dent on your actual grade. The final exam does. The final exam by itself is 40%. So you got to be ready for the final exam. So what we'll do today first is to go over the schedule for the final exam, and it's on Moodle already, but I just want to go there just to be sure that we know when it is going to happen. Okay, so to get to the final exam, I'm pretty sure most of you already know how to do it. I would check the actual college final schedule just to make sure that the date and also the time is correct. But if you go to the interactive syllabus, you will also find that. So I'm gonna take a preview here and just search for final exam. And the final exam, according to what I interpreted from the college schedule, is on the 18th on a Monday, and it's going to be from 8 a.m. to 10 a.m. Yep.
Again, are we going to go through all the questions in the lab or no?
Are we going to
go over the questions?
I will go over those questions, but since next Monday I will be canceling the class, I will go over some of those on this Wednesday and some of those on next Wednesday. So I will go over the practice questions on both Wednesdays. Okay. So we're basically trying to wrap things up a little bit here, and I just want to see if you guys have any questions at this point about all the topics that we have gone through so far, especially from the homework assignments. Okay, as you are doing the homework assignments, what concepts do you have questions about? Which part is like, okay, I'm really not quite sure about this part. Yep, go ahead.
The last two homework assignments, like the thing I have been able to do is like writing a script for them, to test if they can actually be read by them.
Okay. You can just use an input file for that purpose. You can just redirect the input into the mastermind program and then look at the output.
Using the caret symbol, right?
Using what?
The caret symbol?
Using the less than or greater than symbol. So that's because they do have scanfs, so that means you can use a test input file to test and check the output file to see if that's what you need, to see if that's what the program is expected to generate as the output. Okay, that's one question. Any other questions? No other questions? Alrighty. If there are no other questions, what I'll do today is to briefly go over the new homework assignment, and then after that we'll go ahead and talk about the most important part of the new homework assignment, which is how do we generate all the possible combinations, and how do we because you're going to have to okay, let me just point to the homework assignment first, and then we'll go from there. It is still in arrays, okay, which is not exactly the right place to put it because it's not using just arrays, but since it's kind of should be bundled with all the other mastermind programs. That's why it is here. This one is called Mastermind Automated, which basically means the computer is going to play the game. The computer is going to take the role to guess the pattern. You are the one who has to write down a pattern on a piece of paper and hide it from the computer. So when the computer makes a guess, then you have to say, oh, okay, I think you got 2 black pegs and 1 white peg. So you are the one providing the feedback, and then the computer will take your feedback to come up with the next guess to figure out, okay, is this it or is it not it? Okay. So we'll take a look at the homework assignment, and we'll go ahead and start with I guess we'll start with the very beginning. Set in a home directory, set up a subfolder called Mastermind Auto. So you can, for the most part, copy whatever you have at this point into this new folder, okay? Because I'm not going to give you, I will give you two files. One is the updated main.cpp, and the other one is the header file mmauto.h. But you can keep most of your other files, including your make file and stuff like that. The source, which means the program code that you'll be writing, should be in main.cpp. I do not think you need to make changes to that one. mmgame.cpp, which is from your current homework assignment. If you cannot get it done for whatever reason, I will do it during the lab time. Okay, so I'm going to do today's homework assignment during lab time and kind of show you the approach I would do, that I will use to do the homework assignment. mm.cpp is really old. The solution is already online. And then mmauto.cpp is the only new source file that you need to worry about. So all your new code should go into mmauto.cpp. What the program does, the program lets you hide the pattern and have the computer itself to guess it. And you are the one who is going to write the program. So this is going to be, I think it's going to be a more interesting program compared to the one before. The homework that was due today is okay, but it's for the most part, just a lot of chore. Okay, a lot of bookkeeping. Oh, need to refer to this member, which is a member of that structure, and it's just a whole lot of understanding how do I get to individual members of different things to get it to work. Now, in this particular program, you can reuse the header file mm.h and mmgame.h. This file defines the necessary constraints and structures of a guess and an mmgame. What we'll do is we'll also create a new header file, which is mmauto.h, and this is the rest of the file. We use the typical thing to guard against pound including the same header file twice or more. You can still pound include it multiple times, but it's not going to cause problems because of this. Line 4 is just going to pound include whatever we already have defined in mmgame.h. And if you remember correctly, mmgame.h also pound includes mm.h. So we have a kind of hierarchy of pound includes. The make file can automatically take care of that. Okay, so the moment you change mm.h, it knows what to recompile and relink to get your program up to date. So the only new structure is this one here. It's called mmauto. And at this point, it doesn't seem to make any sense because it seems like, hey, we can just use mmgame for this purpose. But I am just giving you the extra option. On line 8, the comments says you can define additional members if you think it'll be helpful. Okay, so it all depends on how you want to implement one of the member functions, okay, or one of the functions that works with a mmauto. Yep.
Is there a limit of how many times the computer can guess?
Yes, it will be limited to the same number of guesses of mmgame. So when you look into mmgame, remember we have a number of guesses that you are only allowed to guess. So the computer will be confined to the same restrictions. Okay, so let's take a look at the functions. mmauto reset is basically just the same thing as a mmgame reset. Okay, all it needs to do is to reset the counter of how many guesses have been used. That's it. Okay, so it doesn't really do anything that much more than what you had before. So you just have to figure out, how do I get to that given a pointer to an mmauto instead of a pointer to an mmgame. That should be a fairly easy thing to do. In other words, the function of line 10, at this point should be a one-liner. Okay, it is a one-liner to call another subroutine that we have defined already. Line 11 is a little bit tricky. It is called auto current guess. Okay, so what it does is it returns the address of the member hidden of history. In other words, when you look at history as a member, it is an game, and within a struct game, there is a member called hidden. So I just want you to return it, okay? Because I need that in order to figure out what is the next guess, okay? The computer needs to use that information to say, okay, I'm going to make this the next guess. The next one is auto guess. This is the one that is going to be the most, complicated one. This is the one where the computer has to come up with a new pattern and say, based on all the previous guesses, the history of all the previous guesses, this is what I want to come up with. Now, what I did not write here is the guess has to be stored in the hidden member of the game structure. Okay, so history as a member of an auto will have a hidden member. That array is going to store the new guess. Is that okay so far? Sort of? Okay. Well, I'm just going to put it here too. Okay, I'll finish this and then I'll edit it, just to get all the changes in.
So is it 5 file again?
Sorry?
So is it 5 file again or 4 file?
So with this one, in terms of source files, you have mm.h, mm.cpp, mmgame, and mmgame.cpp, mmauto, and then mmauto.cpp, and then main.cpp. So altogether you have 7 files, which is nothing compared to any commercial project where you will have hundreds of files organized in probably tens of directories. So it's still a relatively small project. It's just divided into different portions. The comments corresponding to AutoGuess is here. AutoGuess attempts to come up with a new guess in the hidden member of member history. Okay, so I did write about it. I just did not read my own notes enough here. It should return a value of 0 if a new guess can be generated. In other words, you call this function, the computer would use its magic to figure out a new guess, okay, a new pattern, and say, hey, maybe this is the actual hidden pattern. So in the case that a new guess can be generated, you return a 0 to indicate, yep, the game is still on. In the case that no new guess can be generated, in other words, you go through all the possible patterns and none of these patterns can fit the existing history, then you have to return a 1 and basically say, nope, I think somebody made a mistake, but it's not me. Okay, because if you give, let's say you play this game with an actual person, if you score incorrectly, okay, you're the one who is hiding the pattern, and you score incorrectly, the other person at some point will realize and say, it's not possible, okay? None of the patterns can fit the scoring that you have given to my previous guesses. So the computer can do the same thing. In other words, the computer can figure out that you might have made a mistake in the scoring and say there's no possible pattern that can fit the history of pegs of scores and guesses. The next subroutine is auto score, which is a pretty easy one. You're not actually going to call score in any way in this case. All you are going to do is to copy this entire the structure pointed to by PG. You just have to copy that to a part of the history of PA. Okay, and there's only one member in PA. So far, it is a game, and you should probably find out which part of game you should copy the guess to, because there is an array of struct guess members or struct guess elements in game itself, and that's where it goes. In other words, you're just basically saying, I have a new guess with a score in it already. Now I want to keep it in, put it into the history, for bookkeeping purposes. Are we still doing okay so far with all of these subroutines? Are there any questions about any one of these subroutines, what it's supposed to do? Question? No? Okay. No other questions? All right. Well, if you guys have any questions, be sure to ask it, during the lecture time, because, if you have a question, most likely somebody else has the same question. Okay, you have to define the new functions in a new file. Okay, mmauto.cpp is the new file. In the file main.cpp, we're going to change it a little bit. So instead of using mmgame.h, we're going to include mmauto.h because we'll be using those subroutines, and it will also automatically include mmgame as well as mm.h. This is how the main program is going to be structured. It has a variable called a. It is an mmauto. It has a variable called finished, which is just an integer. It's more than just a boolean. Okay, I'm just using an integer as a boolean here. mmauto reset will reset the entire game. Okay, it resets the counter of the game game structure that is a member of mmauto. It will reset that back to 0 to basically say, okay, we're starting this entire game from the beginning. And obviously, we are not finished yet. There's no one confirming that we should be finished at this point, and that's why finish is initialized to 0. And then right here, we have the outer loop of everything. It's basically saying as long as we are quote unquote not finished, and AutoGuess is returning a 0, we are going to perform whatever is specified in the body of this loop. Which is basically saying there's no reason for me to exit at this point, and I can still come up with a new guess, okay, a new pattern as the next guess. Are we doing okay so far with this logic on line 10? Questions? No? Okay. Now, the call to mmguess is going to generate a new pattern. Oh, I can see that there should be some questions here, like, what is this? We haven't seen anything like that, a semicolon within the parentheses. I'll tell you what it is. It's a mistake when I type this up. The HTML code got messed up. So this one I have to fix right away because otherwise we can't really read the code. So let me fix this one first. So I was a little surprised that nobody asked, what is that? We haven't seen semicolons within that context. Okay, so let me search for that. I think it was a S semicolon A. Yep, that's what it is. Okay, so we'll take out the S here and save and display. And scroll back to that point. There we go, much better. There we go. Okay, this is much better. So this call will generate a new pattern. Okay, in other words, the computer will figure out, or try to figure out what is the next hidden pattern, that should be guessed. That will be in the hidden member of history of what the pointer points to. Okay. Are we doing okay so far with the entire structure? Like the hierarchy? Okay. So we have a mmauto. Within mmauto, it has a history member. Okay, this is the name of the member. The type of this member is mmgame. But as a member of mmgame, there's a hidden, which is an array of integers long enough to store the entire pattern. Okay. So what I mean is on line 10, this particular member, which is an array of integers, should get the next pattern as a guess. Is that okay so far? Kind of? Okay. And then the next thing I did was here, I basically use my own local variable hidden, because otherwise I would have to refer to it many times. So I just use it once to say, okay, where is the hidden pattern? Okay, the hidden pattern is now pointed to by hidden. which is just a pointer to a const int. The pointer itself can change. It is just that whatever it points to cannot change. I have my local structure called G. Okay, this is just a guess. This time I I have a prompt here, and I'm saying, okay, this is my my current guess. So the computer is speaking for itself and basically say, this is the guess. It is 1, 2, 3, 4. Okay, whatever it is. And to print that 1, 2, 3, 4, this is the loop to do it. It is just a simple for loop. It goes I goes from 0 to, oh, I forgot the int before the I, so it has to be declared first. So I'll fix that later. Int I equals to 0. It declares the local variable I. It goes from 0 to pattern length minus 1. And then for each member, it is going to, for each element in the array, it will print out the number itself, and it will also initialize the pattern member of a struct guess, which is called G, to that particular number. So this way, we are initializing the current guess that will be used later on. Are we still doing okay so far with this code, other than the missing declaration int? No questions about this one? Okay. So if I forget to put it here, you guys should remember, okay, there's a missing int here, because otherwise the compiler will complain and say, hey, what is I? Nobody has defined I yet. So if you put an int right here, that should solve that problem. After that, I just put an end of line, because otherwise there's no end of line, and the next line will be kind of going to the end of the first line, which makes it kind of hard to read. The next one is a prompt. It prompts the end user to score that particular guess and say, enter the number of red/black pegs. Because in some games, people use the black pegs, and I think in some other games, people use the red pegs to indicate the number of pegs that are both position and color correct. So this is just a prompt, and here I am doing this without any error checking. I use a scanf to scan a number from standard in into this particular member. The member is scored black pegs, which is a member of a struct guess. But since G is a struct guess, I can do something like this. And then I print another prompt, which is to enter the number of white pegs, and this gets read into the other member of a guess. So at this point, on line 24, all 3 members of a struct guess should be initialized. In other words, the pattern itself is copied from hidden, and then the number of black pegs and the number of white pegs are read from standard in. And obviously, since I'm not using the return value of scanf for anything, it means I'm not doing any error checking in this case. So you will pretty much have to enter the numbers correctly, otherwise the program will not work correctly. Are there any questions about the program up to this point? No questions? All right. So when we are all done with up to line 24, line 25 is really just copying the current guess, okay, which is represented by local variable G, into the entire game history, which is represented by local variable A. Okay, so it will have to do something in the background to get this done. It's fairly easy because there is an array of struct guess in history. So you have to find out which member is that array, and you're given a pointer to a struct guess, and you can copy it. You can use an assignment operator when one side is an entire struct guess and the other side is an entire struct guess. The assignment operator does work correctly in that case. So it's just one single equal symbol to get it done. But you do have to find out which one it is. It does return the integer, which is which we store into finish. So this way, if for whatever reason it cannot store anything at this point, it would return a non-zero, and then the finished variable will be used earlier. When we get back to the beginning of this loop here, it would be used here. So if finish is non-zero, we will get out of the loop and say, okay, we're done. So this is a good time to go back to look at the return value of auto score. So auto score returns a 0 if the new guess is stored without any issues. In other words, we just put that score back into into the array, not a problem. It returns a 1 if there's no room to store the new guess. Okay, so we are out of room, and we just ran out of number of guesses available. It returns a 2 if the new guess is stored and the number of black and red pegs is the same as the number of pegs in a pattern. What does that represent when we return a value of 2?
Winning the game. Or the computer
Yep,
won.
we got it, right? Okay, so the computer has correctly guessed the pattern. So we're using this as an indicator. By the time we get out of the loop, okay, so this is line 27 is the first line out of the loop. We first check the most optimistic or the most desirable outcome, which is finished being 2. If finished is 2, then it will print, yay, I got it. Okay, so the computer is saying, yep, I got the correct pattern, which is good. Otherwise, if finished is 1, it will basically understand that it has run out of number of guesses. The computer could not get to the correct pattern given the number of guesses that are allowed, and it will just print, I will try harder next time. And what about the other condition? Well, if finished is not 1 or 2, and we are out of the loop, that means the other expression, which is AutoGuess, is returning a non-zero value. The only time AutoGuess is returning a non-zero value is when it cannot find a pattern that can match the entire history up to that point, which most likely, but not most likely, which always indicates that the other person, the person who's holding the hidden pattern, did not score correctly somewhere along the line. Is that okay so far? That's the entire program. So instead of having you to write the entire program, the focus is actually on AutoGuess. That is the most difficult subroutine to write, for this particular program. And you also will probably need another subroutine that you will have to define in mmauto.cpp that I do not need to know, okay? Because you need another subroutine that is recursive just so that you can generate the correct patterns. Are we doing okay so far with this code or not? Just the overall picture, the big picture of this program. Are there any questions about this last homework assignment? It is due next Wednesday because we are not meeting on Monday, so it will be due next Wednesday. So you have a little bit more time to work on this one, but this one is a little bit more complex. In terms of thinking about it, it is more complex, but in terms of the number of lines of code, I don't think this is going to be a whole lot more complex because we have all the basic stuff already. It's just a matter of, how do you make use of all the basic stuff that we have already done so far. Any questions about this? Okay, can anyone recall the general strategy of this particular subroutine, AutoGuess? What are we supposed to do?
Generate and test.
Generate and test. Okay, so we are generating all the possible patterns, which is, okay, so let's say we allow repeating patterns or repeating pegs. So the first one to guess is what? 0, 0, 0, 0, assuming there are 4 pegs in the pattern. Okay? And then what do we do with a pattern that we generate? We have to filter it. So what is the filtering mechanism? Score. So we are assuming that 0, 0, 0, 0, 0, 0, 0, 0 in this case is the actual hidden pattern. And then what we do is we call score on every single guess that we have stored in the history. In other words, we look back into time and say, okay, I have guessed this particular pattern before, and I got this particular score. If the actual hidden pattern is 0, 0, 0, 0, 0, 0, 0, would it have given me this particular score? If the answer is yes, that means according to that one single piece of history, 0, 0, 0, 0 can still be a hidden pattern. If the answer is no, it means 0, 0, 0, 0 cannot possibly be the hidden pattern because it is not consistent with the scoring from the past. Is that okay so far? No? Yes or no? Kind of? Okay. I'll do the next thing that is good for the demonstration here, which is to play the game, right? So as I play this game, I am going to point out, what you're supposed to do with your program. Okay? So I am actually doing the part of what your program is going to do, and this particular computer on the other side is actually doing what you are going to do because you're the person is hiding the pattern. Is that assumption okay? Does everybody understand the perspectives? Okay. So I'm going to click allow duplicates because in your program you are going to allow duplicates. So this way it's not any harder or easier. It really is just the way it is. So what I'm going to do as the computer, I'm just going to enumerate all of these colors here to be 0, 1, 2, 3, 4, 5, 6, 7. So this is making the assumption that the number of colors is 8 instead of, I think, was it 6 in mm.h? Okay, so this is actually a slight variation of that. I'm assuming that we have 8 colors instead of 6 colors. If I try 0, 0, 0, 0, would this be a possible hidden pattern given what I have done so far? Why is it possible? Does it conflict with any scoring from the past? Because we do not have any scoring. The history is empty. Okay, so your program needs to do the same thing. Okay, so you basically are looking for something that proves that the new pattern is inconsistent with your history. If history has a length of 0, that means anything goes. Okay, because you cannot prove anything is inconsistent or wrong. So 0, 0, 0, 0 is just as good as any other guess. Is that okay so far? Okay, so we'll click check. So when I click check here, it basically is your program printing out the pattern and asking the end user to enter the number of black pegs and the number of white pegs. I'm reversing the roles here because the computer, which is the web browser, is doing what the end user should be doing in your homework assignment. Okay, great. So this time, I'm getting 0 black pegs and 0 white pegs. In other words, the end user, when you are writing your program, the end user is entering 0 for the number of black pegs and the 0 for the number of white pegs. Well, even though it seems like it's really, really bad, it's not, because that rules out a whole bunch of combinations. Is it making sense so far? Because now we have a history of one guess, and I can use it to help rule out certain possibilities. Yep.
So at this point, not only should the computer say 0, 0, 0 is the pattern, but there are no zeros in this pattern.
That is the understanding, but it's not really represented anywhere. The only thing that is guaranteed to be represented in your program using the data structures, using Auto, is the guess itself. So you do have to remember that when you guessed the pattern 0, 0, 0, 0, you receive a score of 0 as the number of black pegs and 0 as the number of white pegs. That is something that you have to remember because that is going to help us with the next guess. Is that okay? Okay. So now I'm trying to come up with the next guess. The computer does not think like we do, so I'm going to emulate what the computer is going to do. So I'm going to say, okay, let me try 0, 0, 0, 0 as the actual hidden pattern. Now, if I use 0, 0, 0, 0, which is red, 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 as the potential hidden pattern, would it be consistent with the score that I got right here? It is not consistent. Because if the actual hidden pattern is red, 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 I would have gotten what? 4 black pegs, or in this game, 4 red pegs. But that's inconsistent. So that means 0, 0, 0, 0, or red, 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 is not a good guess because it is not consistent with what I have already. Let's move on to the next one. Okay, So to you, it makes sense that we move on to green, 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 which is 1, 1, 1, 1. But the computer doesn't think the way we do. So the computer is much easier to write a program just to move on to 0, 0, 0, 1, which is red, 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 green as the next potential pattern. Well, that's okay, because we'll just check it against the previous guess and see if it makes any sense. If the actual hidden pattern is red, 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 green, and I got a score of 0, 0 when I guessed red, 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 is that consistent?
No.
It's not consistent, because otherwise it should have gotten me 3 black pegs. Okay? Then we move on to the next one, which is 0, 0, 0, 2. Red, 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 blue. And you would say, but that's really dumb. It is really dumb. That's because we don't want to write a really complicated program, so that it is not dumb. Okay? Okay, but you see the pattern, right? So then it will move on to red, 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 yellow, red, 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 brown, red, 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 orange, red, 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 black, red, 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 white. Okay, none of those, is consistent with the current history. Then where did we go next? We go from 0, 0, 0, 5 or 7 to 0, 0, 1, 0, which is red, red, green, red. It's not consistent, right? It's not going to be consistent. Red, red, green, green is the next one. It's not going to be consistent. Red, red, green, blue is not going to be consistent. So it will try out a lot of stuff that is not consistent, because it is always, everything that has red in it is not going to be consistent, basically. But at some point, it's going to move on to 1, 1, 1, 1, which is represented by green, 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 green. Okay? So when the computer is thinking, hey, maybe the hidden pattern is green, 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 would that be consistent with the first guess, which is already scored? It is consistent, right? Because if the hidden pattern is actually green, 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 and you guessed red, 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 you would have gotten a 0 for both types of pegs. That's good. It is not optimal, okay? There is a better way to do it, but since I'm not looking for the optimal method, this is my next guess. Does everybody understand the general idea of how to generate all the different patterns and filter everything by using the history of all the previous guesses? No? Not really?
I can't really think of a mechanism.
Okay. So from the okay, let's see how we can do this with it on the whiteboard. So what the computer is going to do is to say, I'm going to generate all the possible patterns, okay? And I'll test each one to see if it can potentially be the actual hidden pattern. Is that okay? So it's going to start with 0, 0, 0, 0. It's not consistent. It will go to 0, 0, 0, 1. It is not consistent. And it will keep doing this until we get to 1, 1, 1, 1. But 1, 1, 1, 1 is the first one that is consistent with the entire guess history up to this point. And I just picked the first one that is consistent. So what I'm subjecting this pattern to is I'm going to use this as quote unquote the hidden, and I'm going to use the first entry of the history, which has an array of guesses. So I will compare this one to the first guess and see if I actually end up with the same score as I got when I used 0, 0, 0, 0 as the first guess. So you will have to use score in this particular case. There any questions about this? Yep.
So then we have to make the program compare 0, 0, 0, 0 to 0, 0, 0, 1, and so that
Not compare, just score.
score it so that it knows that the first 3 zeros can't be less than consistent.
No, it's a lot easier than that. You pick out the first item out of your history, okay, which has an array of guesses, right? And there's a counter to also indicate how many guesses you have used up to this point, right? So you basically say, okay, I'm going to go through all the entries in the history until one, I have run out of entries in the history, or one of the entries is conflicting with this particular pattern. It's not giving me the same result. Is that okay? Because at this point on the whiteboard, on the projector, we have one history. We have a history of, guessing 0, 0, 0, 0, but I'm getting 0, 0 as the scores, right? Every pattern that contains a red peg is not going to work because it will be inconsistent with the score of getting 0 black pegs and 0 white pegs. And green, 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 green is the first one that I will encounter. If I generate the patterns like this, green, 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 green will be the first one that is consistent with the previous guess. And that's why I pick it and say, okay, maybe the actual hidden pattern is green, 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 green. Am I explaining this okay, or are you guys still kind of need some clarification? Sorry? Processing, okay. Yep.
So the computer is going to be using score for the 0001, 002 to test that, what the history it has, or?
Okay, let's take a look here. So we have A, which is our auto structure, right? That's a variable of the auto struct kind. It has only one member. What is the only one member here? It's called history. And what is the type of history as a member? It's an game. And which part of game is an array of struct guess?
Guesses.
Guesses, okay. All right, so what I'm going to do here is these are things that are just randomly, not randomly, but is systematically generated. So I take whatever is generated here, I take one of the elements here, and I put these two together through a subroutine that has the logic to say, okay, assuming this is the hidden pattern, and assuming that is what your guess is, let me give you the number of white pegs and the number of black pegs. Which function would do that? It's from the first homework assignment of Mastermind. It's called score. Okay? Now, but that gives you, one, but you have to be careful because you don't want to just pick an element out of guesses here and feed it directly to score, because score does change the number of white pegs and the number of black pegs in the structure. So what you need to do is to make a copy first. Okay, so you want to make a copy, make a clone. Okay, take this element, make a clone out of it, and call it, say, G1. Okay, so you use G1, or you use the address of G1 to pass it into score. When you're done with score, then you do one check. You basically have to compare G1 dot number of white pegs to one of the members of guesses. This is obviously the wrong syntax. Okay. If that works out, then you check the other score. If both scores are consistent, then this particular pattern cannot be ruled out just yet. Then what you do is you move on to the next element. So you have to change the index here, reassign it to G1, which is a clone of the original guess, pass it to score, and then check again to see if the number of white pegs and the number of black pegs match up with the actual guess. Is that okay so far? Does everybody kind of have an idea of what to do with this? I can give you some pseudocode if that is going to help, but I'm not really sure whether pseudocode is going to be more confusing than it is helpful. What do you guys want?
Sure. Yeah.
Okay. With every potential benefit, there is a risk. Okay, so the pseudocode is going to be like this. Okay, assuming hidden is a new guess. Okay, it's a new pattern. This is what we do. So you basically have to say for each historical guess G, do the following. This is obviously pseudocode, so do not ask me how to translate this into C++, because that really is the whole point of a C++ class. So for each historical guess, do the following. Clone G as G1. And the reason why you have to clone it is because when you call score, it will change the guess structure. So you don't want to change the one that is already in the history because you don't want to mess up the history. So you want to clone it first. Okay? So after you clone it, you call score, and the first one you pass is going to be hidden, which is the new pattern, okay, which is the pattern that you are asking, and say, is this a reasonable next guess? Okay, is this a reasonable pattern for my next guess? And then you pass G1, which is the clone of the historical guess, and then after that you say if G1 is consistent with G, which is the clone, basically you're saying, do they have the same score? If they do, if they are consistent, then it's okay. Everything is okay. Else, you basically say hidden cannot possibly be a hidden pattern. So at which point you will have to exit the loop and then move on to the next possible hidden pattern. Is that okay? So I'm going to put in parentheses here. You have to figure out the control structure to do this. Okay. So you basically want to exit the loop and move on to the next next hidden pattern. Okay. But you will have to figure out how to structure this in an actual loop, because that's something that you have to work on that. But is that helping or not?
Are we just going straight to score and nothing should be changed from the original score code?
That is correct. All the subroutines that we have written up to this point, we do not change those.
Okay.
Yep. So that's why you have to make a clone first. That's why you have to make a copy of the element you have to make a copy of the element of guesses, which is a member of history, which is a member of the auto structure. Are there any questions about the general strategy of generate and test? What are we generating and how are we testing? Because that really is the bottom line. The big picture is the more important part. The actual syntax to do it, well, there are only so many things that we have done so far. One is the member of, the address of, dereferencing, and indexing, accessing an element out of an array. Those are the only things that really that has to do with how do we get from here to there. But the biggest question is how do we combine those things to get it working here? Yep.
The thing I'm kind of confused with is that if G1 isn't consistent with G, doesn't that mean we want to guess another pattern?
If they are not consistent, you have to get another pattern. You move on to the next one. So from 0, 0, 0, 0, you move on to 0, 0, 0, 1.
Okay. I thought that was meaning that this is the wrong type of pattern. This is like a fail or something like that. This is not possible.
As you have more and more guesses, most of the patterns will not be consistent, because that's the whole idea. Because when you win the game, okay, assuming you're not just it's not just luck, okay, when you win the game or when you actually guess the pattern, what happens is you are basically ruling out all except for one single combination, which is going to be the actual pattern. That's how this game is going to be won. Is that making any sense? Okay. All right. So, are there any questions about the pseudocode that I have put up here? Okay. Does everybody know where to get the historical guesses, which is actually on the whiteboard right now? Okay. Does everybody know how to clone a structure?
And for the make file, you just add to the file in the make file and then.
Nope, you just add one file to the make file.
One.
Because you don't need to add the .h file. You just need to add mmauto.cpp to the list of CPP files, and everything else can remain the same, assuming you're copying from the other folder. Yeah. So you can copy all the files from the other folder. If anyone could not get the current homework assignment, the one that's due today done, it's okay. I'm going to do it during the lab time, and I will post my solution, and you can use my solution instead. Okay. Yep.
A question about the last homework. We had, like, you saved the guesses, right, in the history pattern?
Yep.
Did we use it?
Nope. It's all setting up for this homework assignment.
I just came to me like.
So all of those things are setting up, for this particular homework assignment. Okay. All right. So if there are no questions about the pseudocode, I'm going to continue the game. Okay. This is my second guess. So I click check, and well, I think the computer is really messing with me this time, because I'm getting 0 black pegs and 0 white pegs from 1, 1, 1, 1 as well. So now I have 2 entries in the history. Is that okay so far? Now this is important because in the previous one, I just demonstrated, okay, given one particular entry in the guess history, this is how we check things out. So this time, how would I generate the patterns? Now to you, which is to human beings, it doesn't make sense to start with 0, 0, 0, 0 again because we tried it already. It doesn't even make sense to have anything that has red or green in it because these 2 guesses have confirmed one thing, 2 things for sure. There are no red pegs and there are no green pegs in the actual pattern. But to make your program remember that there should not be any red pegs or green pegs in it is a little bit more complicated. So instead of complicating the program to remember, what patterns can still be a possibility and which one cannot be a possibility, I'm just going to regenerate everything from scratch. Okay? Yes, it's going to chew up extra processing time, but that's why you have those, quad-core, processors running at 3.4 gigahertz, right? You got to put those processing power to work. So we're going to retest everything from the beginning. We're going to retry red, 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 red. Pick out the first entry out of this array, make a clone out of it, call mmScore. When mmScore returns G1 has its own number of white pegs and its own number of black pegs, compare those to the actual ones stored in the history. And guess what? Should they be consistent or inconsistent? It's going to be inconsistent, right? Because we already tested this one. It would not be consistent with the previous guess. But that's okay. We just say, okay, since 0, 0, 0, 0 cannot be the hidden pattern, move on to the next one. What is the next one? 0, 0, 0, 1. So we're going to retry all of these patterns, and all of them should be inconsistent with the history because they were inconsistent after the first guess. Having more and more guesses in the history will only make more patterns inconsistent with the history. But that's the whole idea. We want that. That is actually a good thing. So by the time we get to 1, 1, 1, 1, which is green, 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 we're going to pass it through to that same mechanism. And guess what? It will be consistent with the first entry of the history with the array, but it will be inconsistent with the second entry because now we have 2 entries in the history. If any pattern is inconsistent with at least 1 entry in history, it is inconsistent. It should not be used as the next pattern. Is that making any sense? Okay, so I would put 1, 1, 1, 1 and compare that to the first entry of the guesses. It will be consistent. But wait, I have 2 entries now in the history. I would now compare 1, 1, 1, 1, 1, 1, 1, 1 to the second entry in guesses, and this time it would not be consistent. Because if green, 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 green is the actual hidden pattern, it would have given me 4 black pegs in the second guess. But since in the second guess I got 0 and 0, that means it is inconsistent. And what would be the next one that I'm going to go for? 1, 1, 1, 2. Now from your perspective, this is really absolutely stupid because why are we even trying anything with a 1 in it? Because now we should know for sure that there are no green text. The reason is it is much easier this way from the coding perspective. So unless you guys want to go for the more complicated coding, which is more optimal, this is the easier way, quote unquote, easier way to do it. So we're going to test out 1, 1, 1, 3 all the way up to 2, 2, 2, 2. So when you compare 2, 2, 2, 2 to the first entry of guesses, it'll be consistent. Because if the actual hidden pattern is blue, 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 then it would have given us 0 and 0 for both red, 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 red as a guess and green, 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 green as a guess. And as a result, because this is the first one, 2, 2, 2, 2, is the first pattern that passes both tests from the history, we're just going to say, okay, we'll use it as our next guess. So the next one is going to be blue, 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 or from your perspective, it is 2, 2, 2, 2. Are there any questions about this particular part? How we are generating these different patterns? No questions? So when I click the check here, that means now I have 3 entries in the history, and well, that is interesting. Okay, but going for the same mechanism, now we have 4. Great. I think the computer is really messing with me this time. All right. So from that one, yellow, brown, brown, brown is going to be the next one that is consistent. This is actually according to the algorithm itself, okay? Because if I assign numbers to the colors, red being 0 and white being 7, this is actually the pattern, okay? Is that making any sense so far? Okay. So there is nothing random in this particular process and nothing that actually resembles intelligence in this particular case. Okay, so even though the program is playing the game, it is just using a brute force approach of generate and test, and using the new test pattern as a history to basically add on to what it can filter out in the next iteration. Are there any questions about this? No questions? Yep.
So when we have one black plate, how do we make the computer know that it has to keep one number?
You don't. Remember what I said. This particular program has nothing in the code that resembles intelligence. It is a brute force approach. It's a brute force approach because, okay, you do not use this approach when you're playing this game because your brain does not function at 3.4 gigahertz. Okay, what is the frequency of a human brain? In other words, what is the speed of transmission from one neuron to the next? It's measured in milliseconds. How does that compare to the processing speed of a i7 processor? What is the units here? Okay, what is 1 giga? 1 giga is 1 billion, right? So I'm just going for order of magnitude here. I'm not even factoring in quad core and all the other crazy stuff, like multiple ALUs within the core and stuff like that. So what is the reciprocal of 1 gigahertz? That should be in the unit of what? Come on, you guys who have taken physics. Should be in time, right? Back to time. Okay, so 1 divided by 1 billion is what unit? What kind of unit are we talking about? Okay, I'll give you a few guesses here. What is that? 1 milli. 1 milli is 1 over 1,000. Is it 1 micro? 1 micro is 1 divided by 1 million. It is 1. What is 1 level below a micro?
Nano.
A nano. Okay, so we are talking about a single nanosecond here. Your brain, the neuron transmission stuff, is really, really slow. It takes milliseconds for anything to transmit from one neuron to the next. Okay, so we'll just make a really optimistic assumption here that it is 1 millisecond. Okay, just to get the order of magnitude right. I'm pretty sure it's off by a little bit, but we'll make it very optimistic. How does that compare to 1 millisecond? A million times. Okay, so the computer can perform operations. If you count discrete individual operations, the computer can do individual operations 1,000,000 times, at least 1,000,000 times faster than your brain can transmit one signal from one neuron to the next one. What your brain can do that computers cannot do is because of the massive connection between the neurons. Okay, that is one thing that your computer cannot do. When you look at the die of a processor, is it a 3-dimensional structure or is it for the most part, a 2-dimensional structure? For the most part, it's a 2-dimensional thing. What about your brain? If you open up, the skull and look at the actual brain, is it flat like a wafer? No. The neurons are going in every direction. Well, not exactly randomly in every direction, but it is a 3-dimensional thing. It is the massive connection of your brain that makes certain things easy for us, but it's extremely hard for a computer to pick up. Okay? But for a game like this, the computer is not going to think the way you are thinking. The computer is going to use the computer will use its strength, which is brute force, okay, which is what we are talking about here. How long do you think it will take a computer to use this approach? Am I writing a program that will take like 15 minutes between each guess? Can someone give me a guesstimate of how long it will take, even with a virtual machine, because a virtual machine runs quite a bit slower than an actual machine? Will you be able to tell the actual delay between the guesses? That's it. The moment you enter the number of white packs and the number of black packs and the number of white packs for one guess, it will be almost instantaneous that the computer will give you the next guess. Even when you retry all of these possibilities, it's negligible. The amount of time is negligible. Is that okay so far? So that's why the strategy that you use is not going to be the same strategy as a computer playing the same game. Okay? Okay, I'm just going to play it one more time because this one is kind of tricky. So we'll try to come up with the next guess pattern here. So you can see that we have 2 pegs that are color correct. One is even position correct, but we know there's 1 yellow and 1 brown here. Okay? So the next one, what should be my next guess? So I'm going to give you a wrong one, and we'll basically say, why is this wrong? Okay, this is actually corresponding to, let's see, 3, 4, 5, 5 as a number. Okay? Why would this one not be such a good idea? Oh, I meant to use the next color, which is an orange. Okay, that would still be not a good one to use, but for different reason.
The brown can't be the white because you can't change the brown.
But you're still thinking like a person.
Well, I mean,
to the computer, to your program, why is this not a good guess? Because it is not consistent with one of the previous guesses. Okay. Now it is consistent with the first 4 guesses for sure. Okay. In other words, if you compare this guess with the first one, it's good. Okay, it's consistent. Compare with the second guess, consistent. Third one, consistent. The 4th one, it is still consistent. It is up to the 5th guess that makes it inconsistent. Because if the actual hidden pattern is yellow, brown, orange, orange, and you got a score of a black pack and a white pack out of a yellow, brown, 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 that is inconsistent. Because if this is the actual pattern, the previous guess should have received 2 black packs instead of 1 black and 1 white. That is why you rule out this one and say, that's not going to work. Is that making any sense? Okay, but in the sequential order, what is the next one the computer will come up with? The computer is going to go forward, right? It's going to say, oh, this is not going to work, and it will actually bump up this color. This will still be inconsistent. It will bump up this color. It will still be inconsistent. But at some point, okay, the computer will figure out and say, okay, maybe it is something that's like, Now I have to think about what is the next possible pattern that will make this work. Okay, so I think the next one is going to be this one. The computer. This one is the first one that the computer will come up with. I think that's the next one because it will try to keep the yellow as the first position for as long as possible because of the way we do the generation of the numbers. Okay. Okay. Would this one be consistent? Okay, that's compared to the first one. That's a no-brainer. Compared to the second one, third one, they're all no-brainers. Compared to the fourth one, we have one single color match and position right, and so it's given us a yellow peg. I mean a red peg. Compared to the the last guess, it is still consistent because if yellow, orange, brown, orange is the actual pattern, and I guessed yellow, brown, 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 it would have given me one red peg because of the yellow, and one white peg because, that would not be consistent. Okay, never mind. The yellow cannot be the first one. Okay, so I have to move the yellow out of the way and make it the first one. I think that's the one.
That wouldn't be consistent either.
Hmm?
That wouldn't be consistent either.
That would not be consistent either because of that. And
Because then what would be your red peg?
but I have to
Or
think
black?
like the computer to figure
Yeah,
out what
but
the
it would
next
look for
pattern
which
is
one
going
was the black, right?
Hmm?
It would look to see which one was the black peg, and neither of those are in the same position, so.
Right, but I'm trying to think from the computer's perspective to figure out how it will generate the next pattern. We know there's one yellow and there's one brown for sure, so it would have exhausted. Okay, the yellow has to be here, and the brown cannot be one of these three positions because if it did, then it would not have worked. So the brown has to be here, and the yellow is being here. No, the brown has to be one of these three positions.
It's gonna go to like orange for the first one.
Yeah.
Yeah, so it's.
Yep. And since it's going for, let me check to
Yeah,
see
the
if
next
this will work.
Yeah.
That would, okay, so that would give me one black and one white, so that would work. So according to the computer's algorithm, because we have to go sequentially, that's the hard part is I have to think using the same pattern as the computer itself because I can no longer think like a person, I have to think like the algorithm. So this is the first pattern that will match all of the, that will not be filtered out, okay? And as a result, I will just pick this one as the next guess. Is that making any sense? Did everybody understand why I had to switch around a little bit? So because I'm no longer thinking like a person, I have to think about from the program's perspective, what would be the next one? Okay, so this one gives me 3 white, 1 black, and 2 whites. Okay, so now I have to find the next sequential pattern that is going to make this work. Is that okay so far or not? Okay, on Wednesday, I think I know what I need to do on Wednesday. On Wednesday, what I'll do is I will finish this program myself, okay? And then I'll use my program on one side, I'll use this screen on the other side, and pitch my program against this particular website. So this way what you're supposed to enter and how the program is supposed to input and output. Okay, so I think that will clarify the behavior of the program and also help you, understand what test cases you can use to test this particular program. Yep.
I'm still a little bit confused about how the computer checks against the white peg and the black peg to make the decision on the next issue.
Okay, what the computer is doing, okay, I'm just going to pick something random here. Okay, so I'm going to pick something that is completely random. Okay, so this is completely random. It's not using the algorithm itself, okay? The question is, can this even be the actual hidden pattern? Now, how do we know whether this can potentially be the hidden pattern? Well, we have to compare it to all the previous guesses, right? If you compare this, okay, the first 4 are kind of trivial, so I'm going to start with this one here, okay? So if this is the actual pattern, black, brown, orange, and yellow is the actual pattern, it would have been consistent with yellow, 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 giving me a red peg. Is that okay? How about the next one? Well, the next one would have given me one red peg because of the brown here, and one white peg because of the yellow here, so it would still be consistent. What about the last guess that we have done so far? The last guess, okay, if black, brown, orange, and yellow is the actual hidden pattern, and I guessed orange, yellow, brown, orange, then I would not have received any red pegs because none of the color is at the right position. Does that make any sense? So what do I do after this? I move on to the next available pattern. In other words, I'm just sequentially searching for a pattern that will meet all of the requirements based on the history of all the previous guesses. Does that make any sense? So the computer or your program for this homework assignment is not really intelligent in any way. It is really just using brute force and say, I'm going to generate all the possible patterns here, and I would evaluate each one and see if it can be the actual hidden pattern based on the history of all the guesses. The moment it finds one that can be the actual potential hidden pattern, it just says, okay, we'll use this one as the next guess. But the feedback from that guess will add to the history, which will help to eliminate even more possibilities in the next guess. So hopefully within the number of guesses that are allowed, it will get to like one single possibility, which has to be the right one. So that's the general strategy of your game. I think in the previous class, I also illustrated how to generate all of these patterns. You guys still done? Sorry?
You did it on the whiteboard though, so we won't be able to look at the...
I did it on the whiteboard?
I think you should.
I actually ran it too.
Oh, you did? Okay.
Yeah, I did it during the lab time, and I think I recorded it. Did I record it and upload it?
Yeah.
Okay. So that would be a good basis to start with. Okay. So let's go to the website here. Just want to show you guys how to get to all that stuff. So that would be 360 on Monday, and it would be the lab portion. Nope, it's not uploaded.
I think it was 27.
But it was, oh, okay. Yep, okay, it is on the 27th. Yep, that works. Yeah, this will look completely different from yours because I was playing with it and say, let's assume there are, I cannot remember, this looks like a 40? Yeah, 40 pegs in one pattern, and I was just testing to see if the program is going to at least seem to work with that one. All right, are there any questions? So what would be your generate and test pattern look like? Okay, let me give you the pseudocode of that one too. Okay, so to generate and test, your code is going to look like this. Okay, generate and test. Okay, generate and test will receive two arguments, and you will have to kind of decide what kind of argument or the type of the arguments. So one would be the pattern, which is a pointer to point to the pattern itself. One will be the position, which position am I responsible for, and one will be, let's see, number of pegs. You have to pass that one too because you should not use the global variable, okay? To do this recursive subroutine, and it's going to have to return a value. Okay, you have to return something that indicates whether something can be the actual pattern or not. So I would write a subroutine like this, okay, and to use my own convention, you basically use uppercase to separate the words. So this will return 0 if the pattern does not work out. Returns 1 if the pattern is consistent with all guesses, which also means you need one more thing, which is the minimum of what you need would be the array of all the guesses, but I would just pass the entire game into it. So you have to pass an game into it as a parameter. Because without the game structure, there's no way to check for consistency. So that one has to be passed. Are there any questions about this subroutine? It is going to be recursive. That's the only way to do this, so that I can change the number of pegs in a pattern and you would not have to worry about it.
What is the position parameter for?
It's for, okay, so think of it this way, okay? So think of, okay, you three here and me are responsible to do this job here, okay? To generate patterns and figure out the first one that is consistent with the history of all the guesses, okay? So let's say I'm the first call, okay? I'm the one who gets called first, the first invocation of this subroutine. So what I will be given with is a pointer to the pattern. So somebody gives me a pointer and say, okay, so whatever the pattern is going to be, this is where I want to store the pattern. Okay, so pattern is going to be a pointer to an integer, which is an array. Position is, which position within this pattern I'm responsible for. Since I'm the first one, it'll be 0 for me. Okay, number of pegs is the actual total number of pegs. So in the current game, it is 4, which means there are 4 pegs in a single pattern. And then game is a pointer to an game structure, so that it stores all the historical data. So the first call is going to be called to me, and position is 0. So I'm responsible for all the possible values of position 0. So I'm going to put a 0 into position 0 to initialize it. What about the other 3 positions? You go like, well, I don't really feel like doing it, so I'm going to let you do it. So I'm going to call the same subroutine, the second invocation. The second invocation, which is to you, would have the same parameter of pattern, because you still have to pass it along to whoever needs to specify the other parts of pattern. I specified the first element of pattern already. You have to specify the second element. Okay. But the position will be up by 1, so to you it will be position 1, not 2, because we come from 0. Number of pegs, you should keep it the same because we are not changing the number of pegs. And then game should still be the same pointer because it is still the same structure that stores all the history. But you are not going to do all the hard work either. So you pass it on to the third invocation, where position is up by 1, but all of the other parameters remain the same. So your responsibility as the third invocation is to make sure the third element of the array is also initialized. Okay, so by this time it will be 0, 0, 0, but the fourth element will still be undetermined. So now you say, okay, I know there's more to specify, so you pass it on to so you call again for the fourth invocation. But you being the fourth invocation has more work to do, because you realize that your position is the last one, so you will finish up specifying the value of the last position, but you're also going to be responsible to use game to check whether that particular pattern is consistent with all the past history or not. Okay, so let's say you figure out that, hey, with me specifying a 0 is not consistent, then you can move on to 1, 2, 3, 4, 5, 6. But let's say you have tried everything that you can do and it's still inconsistent. There's nothing you can do to make the patterns consistent. What are you going to do? You throw your hands up and you say, I give up. You return a 0. Who's going to get that return value? The third invocation. So when you get a return from the invocation that is a 0, that means, okay, with the first 3 elements set to 0, 0, 0, there's no way we can find something that is consistent. So what are you going to do? You do the least amount of work possible, right? You say, okay, I'm going to change the value of the third element to 1 instead of 0. And then what do? You tell him to do it again. You say, okay, now you figure out, whether there's a way to make the fourth element any value that will be consistent. If he says comes back and throw his hand up again, and then you have to up it again. So let's say the third invocation, who is responsible only for the third position of the entire array, and by implication the fourth as well. So let's say there's no way you can make it fit. What are you going to do? you would throw your hands up and go like, okay, I give up, I cannot make this work. And who's going to get that message? You're going to get that message, right? So what are you going to do? That's the second invocation. Well, you're only responsible for the second element of the entire array. So you basically say, with the second element being 0, there's no way we can find a pattern that works. So what are you going to do? The minimum amount of work. You change the second element to 1, and then you tell the other 2 guys and say, try again. See you later. So when they come back and say, nope, cannot make this work either, you up it by 1, right? But you can only do so many things because only from your perspective, you can only go from 0 to 5 in the actual game at this point. So what if you have used up all 5 possibilities as the second element? You don't have anything to do anymore. You return back to me and say, okay, I cannot make this work. So me being the first invocation will now change the first element to 1 and then give it back to you again. Where do you start?
1?
Nope. You start with 0 again because every position is independent to the other positions. So when you get called again, you always start with 0 for the position that you are responsible for. Is that okay? That's how we're going to do it. Okay, and that's why we need all of these parameters. One parameter to the pattern itself. Now the parameter to the pattern itself is necessary because the last person needs to get a hold of the entire pattern and say, this is potentially the hidden pattern. Is it consistent with the entire history? That's why it has to be passed along.
So this is the point in your program that would tell it that you found or checked all the guesses, and obviously the player.
That's the potential answer. Okay, so let's say you everything return back to me. Okay, and in my own loop, okay, I have used up 0, 1, 2, 3, 4, 5 already as possibilities for the first position. But because I called all of you to get all of the other combinations for every single other position of the elements, checked, and nothing is working, so I'm going to throw my hands up, right, and say, okay, I cannot find a pattern either. But when I return back to the, where is it? And when I return back to Auto Guess, okay, Auto Guess will say, oh, there's no pattern that can be generated that meets the requirements. That is when Auto Guess is going to return a 1 because no new guess can be generated. Because everything is quote unquote filtered out, which means what the end user has entered something incorrectly or intentionally tried to trick you because there's no single pattern that meets all the requirements. Okay, I can give you one particular way to test that one. If the number of pegs per pattern is 4 and you enter like 5 white pegs, that will break the program. The program should always come back immediately and say there's no pattern that will give you this score. It makes sense, right? If the total number of pegs is only 4 and you get 5 white pegs as a score, it should not meet no pattern can meet that requirement. And as a result, it filters out everything, and the program will come back and say, you made a mistake somewhere. That's what the main program is going to do. Are we doing okay so far with these concepts? So even if you're even if you're still not entirely sure what you're supposed to do with this program, start thinking about it. Okay, start thinking about the big picture and what your program overall is supposed to do. What I will do on Wednesday is I will finish my own Auto game, okay, and I'll run it in the class, and I'll be basically running it against the website. So in other words, I'll be using my program to play the mastermind game, so that this way it will illustrate what your program should be doing, when it is being tested. Is that okay? sort of. Okay. And as I said a little bit earlier, the key to this particular thing is going to be the generate and test part, okay? So even before you know how to filter out things using game, just ignore that parameter, okay? Just make it so that generate and test can give you everything from 0, 0, 0, 0 up to 6, 6, 6, 6. But you have to make use of the constants that we define in mm.h, because otherwise, if I change those constants, your program would not be able to work consistently. So I would use the time to do that part first, okay? Which should be pretty easy because that code is already done as of what, last Wednesday. I did it last Wednesday, so you have to watch the lab recording from last Wednesday, integrate that into your own code for this homework assignment. So if you have the generate and test mechanism done, even though the test part is not done yet, it will be easier, much easier for you to work on it from that point on. Are we doing okay so far? So the objective is to get generate and test done so that you can at least generate all of the patterns. You can basically say you fail everything, okay? Just say everything fails, so so there's nothing actually passing the test, because that one is just dependent on game to check all the historical guesses. All right, well, that's the end of today's lecture. This is going to be your last homework assignment, but it's going to be the bigger one, and I think it will be more fun to work on too. You just have to start early. You do have 2 more days to work on this one, but you have to start early with this particular one. All right, so I'm going to take maybe a 5-minute break myself, and then I'll get started with the homework, with the solution to the homework that was due this morning. So this way, for those of you who did not get game done, you can use my solution to work on the next one.